Hi, everybody, and welcome back to Chee-Tash. My name is Chris, and today we're going to take a trip back down memory lane and pick up where we left off in the book Eloquent JavaScript by Marijan Haverbeek. It's been a long time, I think actually like almost a year since I've done an episode on Eloquent JavaScript. If you guys have been following along, we have pretty much finished the book Clean Code, besides from some of the appendices and like extra chapters at the conclusion of chapter 17 that we haven't really gotten into, but for all intents and purposes, Clean Code is done. Maybe I might go back to it and do some additional videos regarding some of the topics, maybe in the appendices. But I decided, you know what, why not keep this coding and software development train going? And I know a lot of people have been asking me about Eloquent JavaScript, so if you guys, it's been a long time, but if you guys remember, we left off at chapter 6, The Secret Life of Objects, and I've been kind of going through topic by topic on this one. So rather than going through the entire chapter, I'm picking like the headings or the headlines of each chapter. So we're in the polymorphism section. So this will be just a very, very short video on polymorphism. And we talked a little bit about polymorphism in the context of clean code and how you can use that to better structure and better organize your code. If you guys remember the single responsibility principle from clean code, a class should only have one reason to change, or it should really only do one thing. And polymorphism is kind of a way to do that. Polymorphism allows for basically inheritance. So from a Java OOP standpoint, it's where classes can be treated as instances of a class. So if you have a vehicle class, you can then create a car class, a truck class that can extend the vehicle class. And so it inherits certain properties that all vehicles are going to have. This allows for you to then create and customize your cars and your trucks and your electric vehicles and your motorized scooters and all that stuff. You can customize the properties and the functions / methods from your vehicle class to fit the purposes of your concrete classes that inherit your subclasses. Let's call them that, your subclasses that inherit from vehicle class. So in Java and OOP, you can achieve polymorphism in a couple different ways. Now, this is what just my research looking into this on ChatGPT, just for entirely, full disclosure, ChatGPT, that you can have compile time and runtime. You can have polymorphism at compile time and at runtime. So at compile time, this is where you would use method overloading. At runtime, it's method overriding, and they're two different things. Method overloading is where you have a method within the same class, and you can have methods with the same name, but you can have them with different parameters or numbers of arguments. So we're going to see an example of this on the next slide. Runtime polymorphism in Java is where you have method overriding. So this is where you override the functionality of a superclass method or a method that a method from a class you're inheriting from. Like we said in the vehicle class, all vehicles are going to move, right? Cars are going to drive, motorized scooters are going to pedal, or like bicycles are going to pedal, something like that. So you would then override the move method to then print out something specific to that type of vehicle. And this is typically used with the override annotation above the method. So on the next slide, you can see on the left-hand side is method overloading. So you have an add method, but it's returning two different things. It's taking in different types of arguments, and it's returning something completely different, right? This one's returning a double, and then the top one is returning an int. On the right, This is runtime polymorphism. This is typically where you see the extends keyword, and it's where you see something actual inheritance happening. So you see here that the dog extends animal, and then it inherits and overrides the make sound method from animal. And I guess maybe, oops, I'm sorry, guys. Maybe in this example, ChatGPT didn't produce the override method, but you guys see this I see this a lot with Lombok annotations if you're using Spring Boot, and you can override the toString method, or you can override the equals and hash code method. So I think sometimes I guess you do have the override annotation. It's just at override, but I guess in this case they didn't. So 2 different ways to achieve polymorphism in Java/OOP. Now in JavaScript, it's slightly different. Even though JavaScript, there is object-oriented programming in JavaScript, but it's different in just the fact that JS is a very dynamically typed language, whereas Java is static. What do I mean by that? I mean that in JS, types can change, and you don't have to declare types, whereas in Java, you do have to declare types, and you do have to, if we go back to the previous slide, you do have to declare these types. If we're looking at the calculator class over here on the left, you have to mention that the argument A is an int, and argument B is an int, and it's returning an int. In JS, you don't really have to do that. So polymorphism is achieved differently in JS. You have to go about it in a slightly different fashion. Like we said, you can use dynamic typing. That's one way to achieve it in JS. So this is where a type or class of an object is determined by its behavior rather than its explicit type. And again, you don't need to declare variable types, which means that they can change. So polymorphism in JS takes a little bit different flavor. It looks a little bit different. So on the next slide here, you can see what we mean by dynamically typed, especially on this bottom screenshot. So where you have this declaration and instantiation of this X variable, and you're assigning it a number, the number 5, but then later on, you're changing it to assigning it a string. And then even later on, you're assigning it an array. In Java, this would not be allowed. You would have to name these all different variables, but JS allows for dynamic typing. Your variables can change type. You don't have to declare that, hey, X is a number or X is a string, etc. So keeping this in mind, look at the top screenshot where now we have the add function like we did in Java in the previous slides. But in this one, we're not declaring that A is an int or B is an int. So you return something completely different depending on the type. It's very dynamic. So if you do pass in a 2 and a 3, it's going to return 5. But if you pass in strings, it's going to concatenate those strings. So very dynamically typed, a different way to achieve polymorphism. And I know that JavaScript does have classes, but the classes are different in a way because of this thing called prototypes. So I think, yes, you can create, like, you know how you create classes in Java with the class keyword, the public keyword? You can do that in JavaScript. But I just don't, I think we've talked about this in previous videos where it's like, I just don't know why you would do that. It's not really meant to do that. It's meant to be very, again, just very dynamic and not very hard-coded like that. You would be best served to have a back-end server doing that job for you, like a back-end Spring Boot project doing that for you, and having those classes be tied to tables in your database, etc. So objects in JS are instances of classes, right? Same thing as Java, but there's no strict class definition. And I guess maybe that's one of the other big differences. There's no strict class definition. But everything in JS, objects in JS are prototype based. Now, what do I mean by that? Now, I believe we had a video on this, again, a long time ago. Sorry, guys. Where we talked about prototypes. And basically, prototypes are like, this is like the class object in Java, where everything inherits from the object class. That's why you have to override a toString and an equals hash code in your Java classes. But a prototype is the fallback set of properties in JS. If an object does not have a property, its prototype is searched and so on. So this is like the root class of all objects in JS. And it's what you're going to use to achieve polymorphism, or it's one of the ways to achieve, it's another one of the ways to achieve polymorphism. So ways to do polymorphism in JS, so you can type check in a function, and this is called duck typing. So if you guys see this method, we're checking if the argument that you're passing into the function is of a certain type. And if it is, we're going to run that method. If it's not, we're going to do something else. So when you call this start vehicle on a car and start vehicle on a bike, potentially, this is assuming that you've created a car object that has a start attribute, and that start attribute is a function. So I'll actually show this to you on the next slide. So this is one way to achieve a polymorphism through duck typing. So if it looks like a duck and quacks like a duck, you're going to do what the duck does. So if it's of a type vehicle and the vehicle has a start attribute and it's a function, we're just going to start that vehicle. So what I was mentioning in this slide, and this will be the last slide, folks, this is where prototypal inheritance comes in. So one way to do polymorphism in JS is through duck typing. The other way is through prototypal inheritance. This is where you inherit properties and methods from other objects, and you use one way to achieve it. And I think there's got to be other ways to do it, but you can use this object.create method to create objects using other objects as templates. So we have this vehicle object. It's using the bracket notation. It has a start attribute, and you guys can see right now the link to the previous slide here, where we're type of vehicle.start, and we're checking if it's a function, right? Well, this is what you would do to create these instances of car and bike, because we're looking to see if the vehicle has a start attribute and it's a function. And you can see here, oh, I'm sorry, guys. Let me go back. Skipped a little ahead. I got a little too click happy there. But in here, we're creating this vehicle prototype, right? This vehicle base class, basically. And it has a start attribute, which is a function where we're just printing vehicle started. So we're using that to create a new object called car. And right here, you can see how you can add attributes to this car. You can add a brand Toyota. You can add a size, 10 feet. You can add a weight, 1,000 pounds. So now when you call car.start, car inherits the start method from vehicle. So this is entirely valid. It's going to say vehicle started. Or you can say start vehicle and pass in that car object that you just created. And this is going to check if it's of a type of vehicle, and if the start method is a function, and it's going to call it here. So two different ways to achieve polymorphism in JS using those two methods there. But that's going to do it for today. I know, a very short chapter just on polymorphism. Again, polymorphism essentially means you are inheriting from something else. In Java, it's going to look slightly different in a statically typed language than it is in a dynamically typed language like JS. And hopefully that kind of cleared things up. I know this is a very short video, but I'm going to start getting back into Eloquent JavaScript because more and more I've been working in JS more at work, so this helps me out. Hopefully this helps you guys out, and let me know if you have any questions. Leave them down in the comments. We'll be back next time with some more Eloquent JavaScript. Maybe even might start another book. I think it might be time. But guys, thank you very much for listening. Go check out the podcast and the interviews that I've done over there, just with random assortment of guests, just interesting people, interesting YouTubers, authors that I've met. And just, guys, thank you so much for listening. My name is Chris. This has been Chee-Tash. Take care, everybody.